All right, well, today we're starting at section 1.1 and we are starting with the basics. We are laying down the tracks. We're just making a foundation. There is no house to flip yet. We haven't even gotten that far. So lesson 1.1 is titled Identify points.
Real by David.
Oh, I know, it's kind of weird. Yeah, sorry. Identify points, lines, and planes. And there's some other stuff that's going to be tossed into this section as well. I hate notes that have just fill in the blank stuff. Anyway, there are 3 undefined terms in geometry. And they're undefined, but they have like an accepted definition. It's kind of weird. So they are, oddly enough, point, line, and plane. So yeah, it says they're called undefined because these terms do not have formal definitions, but there is agreement about what they mean. So it's kind of a weird thing. And I swear this is a carryover from Euclid's book, where it's like, well, these don't have definitions because everybody knows what they are. It seems strange. All right, so what do you suppose has no dimension and is represented by a dot? A point. And here we go. The most fundamental object we can think of in geometry is a point. And in our geometry books and in Euclid's geometry book, if you had a point, in order to reference it and talk about it, you would give it a name. And so we're just going to name them with letters. So right there is point A. But in geometry, anytime they just give a letter, they're talking about a point. So if you just say, hey, look, there's point A, you can just write A. And it's going to be accepted as you're referencing a point. All right, let's move on. So if we take a bunch of points and put them together, we're going to have something that has 1 dimension, and it's represented by a line with 2 arrowheads, but it extends without end. We're talking about a line, of course. It has 1 dimension. Also, something you may remember from Algebra 1 is this postulate right here that says through any 2 points, there exists exactly 1 line. And that's something we learned about in algebra. Okay, so you can name a line in several different ways. So let's get an example down real quick. So let's draw a line. And what you'll often see, it's not required, but you'll often see a italicized letter off to the side. For example, and typically it's L. Guess why? Because it's a line. So they'll have some letter that's off to the side. See how there's no dot with it? And so one way that you can name this that I have so far is you can say this is line L. But what's more useful, in my opinion, is you know that a line has to have at least how many points? 2. So what you'll often have is at least 2 points on a line that are named. And so now you can name this line a few different ways. You can say, well, this is line AB. But I don't often write out the word line like that. Instead, what we can do is we can say AB, but then we draw a little line over the top. So that's the preferred way to name it, in my opinion. Okay, this is the preferred way. Is you write AB, and then you draw a line above it, complete with arrows, right? Now, because lines extend in both directions either way, there's no, you could also say line, instead of AB, you could say line what? BA, the order doesn't really matter. And so then you can say, BA with the little lines over it like that. So this is how you name lines. And all throughout the year, we're going to have points and lines that we're going to be naming and describing and finding out the relationships. Now finally, we're going to talk about a shape that has two dimensions. And so it is represented by a shape that looks like a floor or a wall, but it extends in all directions without end. So it's a two-dimensional equivalent of a line. So it's a plane. And to name a plane, you either name it by the letter in the corner or by 3 points that lie in it. Okay, so let's get a little picture here to describe this. Am I going too fast? No. Okay. So when you draw a plane, the accepted way to do it is to draw a slanty box. And it doesn't have to be perfect in any sort of fashion. Just make it slanted. And then if you just see, usually it's just a capital letter. Sometimes it's bold, actually. But you'll just see a letter in the corner. In this case, a little M. Well, that means this is, plane M. That's one way to name a plane. But what's interesting is if you have some points in a plane, we'll say B, A, and C. 2 points determine what kind of shape? A line. So to name a plane, we must use, if we're going to use points to name it, we've got to use how many? 3. So have you guys ever heard about how in like photography and stuff, they use tripods? And it's always a steady surface. It's because those 3 points can always make a plane. They can always find a plane in uneven surfaces. So it's kind of interesting. So it's that same sort of idea. So what we can do if we've got 3 letters here is, and unfortunately with planes you actually have to write it out each time. So you could say, instead of saying plane M, you could say this is plane BAC. And remember with this one, it's kind of special. You have to write out plane. You can't draw a little plane above the 3, even though that seems like that would be fine. But the customary way to do it is to write out plane BAC. Or you can mix it up and say plane, I don't know, what do you want? ABC. ABC, right? Or plane cab, yeah, CAB. And there's probably another option or 2.
I'm still kind of confused on what makes it a plane.
Uh-huh.
Does it have to be a complete shape, or does it have to be a?
It's definitely a shape. It's like a. Oh, you mean like how you represent it on the paper? How you draw it out?
Why is it just it's almost just like an angle within? Is the plane the whole shape, or is it the?
Yeah, the plane's the whole shape. So we can't actually draw a real plane on our sheet of paper because it extends out forever. So instead what we say is we try to draw a surface. It's a surface, and then you've got to use your imagination. You got to say, oh, okay, so this is plane M, but in reality it's doing what? Spreading out forever.
So that's why you have to pick the points within
Yeah, I suppose. Another way to think of it is through any 3 points, you can take like a slice, like a sword or something, and slice through them all at once in one swipe. That swipe that is made by the sword is a plane. And it extends out forever. So we've got a lot of planes that are represented in this room. They're not true planes because they actually stop at the walls and the floor. But our ceiling is in fact a plane, isn't it? If it extended out forever in all the directions that it's in. Our floor is a plane. But in reality, if I say, all right, this edge right here is a point, this right here is a point, and this right here is a point, there exists what? A plane that would hit all 3 points. Are you guys with me on that? So even if it's not formally drawn, if I add another point out here, if I add a point outside that's not in the drawing that I've made for this plane, if I put a point outside of it, it's outside the plane, and that's kind of, what's that?
It's not on
Oh, I stepped on the cord. All right. Thank you, Hannah. Okay. So if I were to add a point outside of this plane, guess what? There's another plane that would be between that point, and that point. That would slice through a different direction, right? Or I could make a different plane between this point, and then that other point. And there would be another plane that exists that would slice through that way.
This is gonna be a tough year, isn't it?
So is it like a line of best fit between the 3 points almost?
Yeah, but it extends instead of 1 dimension, 2 dimensions. All right, so let's go on a little bit, and then we can see how you feel when we ask some questions. So there's a few definitions we're going to look at this point. So the first definition we're going to look at is collinear points. Collinear points are points that all lie on the same line. Well, it's kind of silly here, but what do you suppose you can call points that are not all on the same line? Non-collinear. Non-collinear points are points that are not on the same line. So let's take a look. Here's an example of collinear points. Draw a line, right? Draw a line and make sure that the 3 points you put all have to reside where? On the line, right? So S, P, and T are collinear. Non-collinear points you could represent by drawing a line, placing 2 points on it, and in truth, aren't any 2 points going to exist on some line?
Yes.
Okay? But then how are you going to make sure that this third line is definitely different? The third point. You just place another point outside of it, and then you can say, all right, these 3 points are non-collinear.
What's a collinear if there's 3?
What's that?
It's like, it's collinear, but like it has to be 3 points on the line? Or is it like?
Well, it's just any 2 points have to be collinear. There is always a line that exists between 2 points. And so I just use 3 because that's the first opportunity for them not to be collinear.
So if it's just 2 points, they're collinear?
They have to be, yeah.
Yeah.
Yep, they have to be. And then, I've already let the cat out of the bag, but through any 3 points not on the same line, there is exactly 1 plane. So if you've got CAB and you slice through all 3 of those points, it's going to create a plane. Let's flip it over and see what else we got. what do you suppose points are that lie in the same plane? Yeah, that's where we're going with this. Coplanar.
Like for real?
Yep. Coplanar points are points that lie in the same plane. What do you suppose points are that don't all lie on the same plane? Non-coplanar. And to draw an example of coplanar points, you're going to want to draw a plane and make sure they're all where? Inside it, right? So you can go A, B, C, D. Look at those coplanar points. And then an example of non-coplanar points. Go ahead and draw a plane. Put a few points in there. But where would we have to put another point in order for them to be non-coplanar points?
Outside of the plane.
Anywhere outside of the plane. Anywhere outside the plane.
If the plane goes on forever, then how can it be outside of it?
Because it's only two-dimensional.
It's only 2 dimensions, so it's going in the third dimension, isn't it? It's either above the plane or behind the plane. Does that kind of make sense?
Yeah.
Now, what you got to be careful with is any 3 points are going to be coplanar, right? If you have 3 points, that's that tripod, isn't it? There's going to be a plane through them. So if you're naming non-coplanar points, you got to be careful. You're going to have to name 4 points or more. All right, let's finish things up today with terms that can be described using known words such as point or line are called defined terms. And we're going to look at some defined terms tomorrow. So what I'd like to do is kind of flip to the back real quick. Your assignment is going to be page 5, 1 through 45 odds. So you've got a foundation. You can start practicing if you want. We're going to finish these notes up tomorrow, and then you'll have the rest of the hour and the weekend if you need it to finish your practice. You guys cool with that?
Yeah.
So if you want to lessen your burden tomorrow, go ahead and start this assignment. Do you guys know where to find the book? Have I shown you that? Okay, so I'll show you that real quick.
Is it the same thing from last year?
I'm sorry?
Is it the same thing from last year? Algebra class, the big idea?
No, it's not. It's not. All right, so finally, you can go somewhere other than this week. If you go to chapter 1 in Canvas, chapter 1, and then all the textbook ones have G section. So G section 1.1, identify points, lines, and planes textbook. If you click on that, it'll be a PDF. And then you can see what the book has to say. And then you can arrow on over to the skills practice. Any questions for me before you guys get out of here? All right. Hey guys, appreciate it. Thank you.
We just do that on like a piece of paper and then turn it in.